in this video we learn if we have a function which is in this form, then how to find a derivative of this function. For example, if we have a function in the form which is in trigonometric function, power of the trigonometric function, so how to calculate a derivative of this function. So here this is a given thing and we have to find this term, and this is a condition. So let this whole function is u of x, which is equals to sin x into cos x, sin x power of cos x, and v of x, which is equals to this term, which is cos x power of sin x. We can write this equation as f of x, which is equals to u of x, because this whole factor we say u of x, and this is we call the v of x, plus v of x. We have to find f dash of x, means derivative of this term. So by some rule of derivative, we have applied a derivative with this. So basically we have to find this term. So let's suppose we called it a first equation, and this is the second equation, and this is we call the A equation. So now we need a derivative of u of x, and we have to need a derivative of v of x. So if we apply a derivative, before we apply a derivative, because we have a function of any trigonometric function to the power of the trigonometric function, so in that case, whenever we have in this type of situation, we have to apply a log, natural log. So we have to apply a natural log on both sides of first equation. So ln u of x, which is equals to log ln sin x power of cos x. So here, by the rule of the log function, that whenever the power can be multiplied with the outside, so we can write here by using the log rule, cos of x and of sin of x. Now to apply a derivative with respect to x on both sides, so after this 1 over u multiply du over dx, which is equal to, here we apply a product rule, first function as it is, derivative of the second function, and 1 over sin of x and derivative of the sin of x, sin of x. Then the sign is plus the second function as it is, ln of sin x, multiply the derivative of the first term, which is minus sin x. 1 over u multiply du over dx, which is equals to cos of x into 1 over sin of x, and the derivative of this is cos of x, plus minus sin of x ln of sin of x. Next step, 1 over u du over dx, which is equals to cos square of x divided by sin of x, minus sin of x ln of sin of x. So du over dx, which is equals to u what the value of u from the first equation. We have du over dx, which is equal to, what's the value of u, which is sin of x power of cos of x, and the remaining term can be written in the same way. Next thing, to find the derivative of v, means dv over dx. So taking natural log on both sides of the second equation, so ln of v, which is equals to ln cos x of sin of x. The power term is in outside, sin of x ln cos of x. So now taking derivative, cos of x. So now here we apply a log rule, which is 1 over v and dv over dx. Here we apply a product rule. First function as it is, derivative of the second function 1 over cos of x into derivative of cos x, which is equals to minus sin x. The sign between them is plus. Second function as it is, ln cos x into derivative of the first function, which is cos of x. dv over dx is equals to multiply by v and minus sin square x divided by cos of x plus cos of x and ln of cos of x. Second equation, the value of v, which is cos x power of sin x into, this term remains on the same, cos of x plus cos x ln cos of x, and this equation is fourth equation. Put third and fourth equation in equation A. So f dash of x, which is equals to sin x cos x into cos square x divided by sin x minus sin x ln sin of x. Cos x sin x minus sin square x over cos x plus. This is final answer of derivation.